Good afternoon, everyone. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. In our last section, we actually looked at how to analyze or solve an ordinary differential equation using substitution. Yes, where we actually substituted y to be equal to uv. Now, in today's class, we are going to be looking at solving differential equation of the form the y all over the x plus py is equal to q, where p and q are both functions. Yes, they are both functions of x or constants. Yes, or constants. Yes. So now, in this case, this is called the linear equation, linear differential equation. So here we are going to be using the integrating factor. Yes. Now the integrating factor is equal to e raised to the power of integral p dx. Yes. The integrating factor is equal to e raised to the power of p dx. So now we are going to be multiplying both sides, both the left-hand side and the right-hand side, by the integrating factor. So here, multiplying both sides by e raised to the power of integral p dx. Yes. So in multiplying both sides, now the left-hand side, that is this side, the left-hand side, will be e raised to the power of integral p dx. Yes, the y all over the x plus, here we have e raised to the power of integral p dx. Here we have py is equal to e raised to the power of integral p dx. Then here we have q. Yes, so now we have multiplied all through by the integrating factor e raised to the power of p dx. Now looking at this equation, now this is the same as saying d all over the x of, here we have y, e raised to the power of integral p dx is equal to, here we have q, e raised to the power of integral p dx. Yes, because if you differentiate this, it will give us this function. Now let's look at it now. Remember we said if y is equal to uv, the y all over the x will be equal to v, the u all over the x, plus u the v all over the x. It therefore means that when you differentiate with respect to x, y e raised to the power of integral p dx, this will give us, now you pick those values, e raised to the power of integral p dx, you differentiate y, and now you give us the y all over the x. Then here you have plus, you pick your y. Yes, y. When you differentiate this, because this integral p dx is the same as saying e raised to the power of px. Yes, because when you integrate p dx, it gives px. So here this is like saying e raised to the power of px. So when you differentiate e raised to the power of px, it will give p e raised to the power of px. And now this is the same as saying e raised to the power of integral p dx, the y all over the x, plus, here we have y p e raised to the power of integral p dx, because this px is the same as integral p dx. So what we have here is the same thing with this. Yes, it's the same thing with this. It therefore means that the derivative of this is equal to this, because when you differentiate this using the product rule, it actually gives this. So it therefore means that now the next step is to integrate both sides. So now integrating both sides, when you integrate the side, you have integral d all over the x in bracket y e raised to the power of integral p dx. Now with respect to x, will be equal to integral, we have q e raised to the power of integral p dx. Then here we have dx with respect to dx. So since this is the derivative, when you integrate this, it gives y e raised to the power of integral p dx. Yes, integral p dx. Now this will be equal to integral q e raised to the power of integral p dx with respect to dx. But remember, yes, that the integrating factor if is equal to e raised to the power of integral p dx. So it therefore means that the whole of the functions there, yes, that is the left hand side, the whole of this function here will be y times integrating factor is equal to, we have integral q times integrating factor, then here we have dx. Now this is the equation, and this is how to express it. Now we have some examples. We are going to be solving some examples, yes, using this method. Yes. Now let's look at example 1. Yes, example 1. Now here, let's pick this. We have x, the y all over the x minus y is equal to x raised to the power of 3 plus 3x squared minus 2x. Yes. Yes. Now this is a linear equation. This is a linear equation in the form of the y all over the x. Yes, the y all over the x plus py is equal to q. Yes, it's equal to q. So it means in this case, to solve this, first of all, we have to divide through by the coefficient of the y all over the x. Now let's divide through by x. So dividing through by x, we have x, the y all over the x, divide by x minus 1 all over x times y is equal to x raised to the power of 3 plus 3x squared minus 2x all over x. Yes, all over x. So now this x, we'll go with this x. And we'll be left with the y all over the x. The y all over the x minus 1 all over x. And here we have y is equal to x power 3 divided by x is x squared. Plus 3x squared divided by x is 3x. And here we have minus 2 all over x. Yes, because 2x divided by x, the x will cancel this x. Here, sorry, we have 2x all over x. So 2x all over x will give us 2. Yes, sorry, it will give us 2. So it therefore means that the y all over the x, minus 1 all over x y is equal to x squared plus 3x minus 2. Now you can also see here that this equation now is of this form. The y all over the x plus py is equal to q. Yes, it's equal to q. So it means in this case, our p, the value of p will be equal to, we have minus 1 all over x. Yes, that's the value of p, minus 1 all over x. And q will be equal to x squared plus 3x minus 2. Yes, remember we said from inception that both p and q are both functions of x or constants. So in this case, they are both functions of x. So now let's see the integrating factor. Now the integrating factor if, we said, is e raised to the power of integral p dx. Yes, e raised to the power of integral p dx. Now let's see the value of integral p dx. Integral p dx will be equal to integral, we have minus 1 all over x dx. Yes, minus 1 all over x dx. And this is the same as saying minus integral 1 all over x, and here we have dx. It means integral p dx will be equal to minus ln x. Yes, minus ln x. And of course, we know this is the same as saying minus 1 ln x. And minus 1 ln x is ln x raised to the power of minus 1. Yes, ln x raised to the power of minus 1. which is the same as saying ln 1 all over x. Yes. Now let's look at the integrating factor. Now the integrating factor, we said, is e raised to the power of integral p dx, and integral p dx is ln 1 all over x. Yes, ln 1 all over x. So here we have ln 1 all over x. Yes, and we all know that this is the same as saying e raised to the power of log 1 all over x base e. So this will go with this, so it means here we'll be left with 1 all over x. So that is the integrating factor. So the integrating factor is 1 all over x. Now look at this equation here. We said the equation will be y times integrating factor. Yes, y dot times the integrating factor is equal to integral. We have q, yes, times the integrating factor, then we have dx. It therefore means that here we have y dot, the integrating factor is 1 over x. So here we have 1 all over x is equal to integral. Now the value of our q, this is the value of our q. Yes, this is the value of our q. So here we have x squared plus 3x minus 2. Yes, minus 2. Then the integrating factor is 1 all over x. Then here we have dx. Yes, we have dx. So it therefore means that what we have there now would be, yes, what we have there now would be, using the equation there, it will be y all over x. Yes, so it will be y all over x. It will be y all over x is equal to, now this will be integral. We have x squared plus 3x plus 3x minus 2 all over x, and here we have dx. Yes, we have dx. It means here we have y all over x. Y all over x will be equal to, we have integral x squared over x plus 3x all over x minus 2 all over x. Then here we have dx. Yes, we have dx. It means y all over x will be equal to integral x squared divided by x is x. Yes, plus 3x divided by x is 3 minus 2 all over x. Then here we have dx. So it therefore means that here y all over x will be equal to, when you integrate x, it gives x raised to the power of 1 plus 1 all over 1 plus 1, plus when you integrate 3, it becomes 3x, minus when you integrate 2 all over x, it becomes 2 ln x. Then here we have plus constant. So it means y all over x will be equal to, we have x squared over 2, yes, plus 3x minus 2 ln x. Then here we have plus c. Yes. Now this is the same as saying y all over x. Yes, y all over x is equal to, here we have x squared all over 2 plus 3x minus this 2 ln x is the same as ln x raised to the power of 2. Then here we have plus c. So now let's multiply through by x. Yes, let's multiply through by x. So it means the left hand side, we have x in brackets, y over x is equal to x in brackets. Here we have x squared all over 2 plus, we have 3x minus, we have ln x squared. Then here we have plus c. So it means this x will go with this x. We have y to be equal to, now x times x squared over 2. That will give us x raised to the power of 3 all over 2 plus x times 3x. That will give us 3x squared minus x times ln x. That will give us x ln x squared. Then here we have plus x times c. That will give us cx. So this is the solution. This is the value of y. Yes, that's the value of y. So So now we're going to look at another question. Yes, let's look at question example 2. Question number 2. Yes, question number 2. We have the y all over the x. The y all over the x plus, we have y tan x. Y tan x is equal to sine x. Is equal to sine x. Now, if we look at this very closely, we'll discover that it has been expressed in the form the y all over the x plus py is equal to q. Yes, it's equal to q. Now remember we said y, p, and q are both functions of x or constant. So it means in this case, the value of our p is equal to tan x. Yes, the value of p is tan x, and the value of q is equal to sine x. Yes, so now let's see the integrating factor. Now the integrating factor is equal to e raised to the power of integral p dx. E raised to the power of integral p dx. So it means here, the value, remember here we said let p be equal to tan x. Our p is tan x there. P is actually representing tan x. So it means that here we'll have integrating factor will be equal to e raised to the power of integral, the value of p. Yes, because we have p tan x, so that will be p the x. So it means the value of p here is tan x. So we have integral tan x, then we have dx. Integral tan x dx. Now let's integrate tan x. Let's integrate tan x. So now integral tan x dx. Yeah, this is the same as saying integral sine x all over cos x dx. Yes, integral sine x all over cos x dx. Yes, now this is a case whereby the derivative of the denominator is equal to the numerator. Yes, so it means in this case, you just tell them, let u be equal to cos x. Yes, let u be equal to this. So our du all over the x, when you differentiate cos x, it gives minus sine x. Yes, du all over the x is minus sine x. So our du, or du rather, will be equal to minus sine x. Then here we have dx, minus sine x dx. So the x will be equal to du all over minus sine x. Yes, du all over minus sine x. So it therefore means that the whole of this integral sine x all over cos x dx will be equal to integral, we have sine x all over u. Remember we said let u be equal to cos x. So it will be integral sine x all over u dot the value of the x. Now the x is the u all over minus sine x. Yes, so it means this will cancel this. So we left it minus integral 1 all over u. Then here we have the u. Yes, and that will give us minus ln u. Yes, minus ln u. And of course we know that the value of u is cos x. So that will be minus ln cos x. So that is the integrating factor. Yes, that's the integrating factor. Okay, yes, that is the integral of p rather. Yes, that's the integral of p. So here, let's look at the integrating factor. Yes, let's look at the integrating factor. So the integrating factor, we said is e raised to the power of integral tan x dx. And here, this is the same as saying e raised to the power of, now, we have minus ln cos x. So here we have minus ln cos x. Yes, minus ln cos x. So now this is the same as saying e raised to the power of ln cos x all raised to the power of minus 1. Yes, and now we give us e raised to the power of log. Here we have 1 all over cos x, 1 all over cos x to base e. So this will give us 1 all over cos x. So this is the integrating factor. So this one is actually the integral of p dx. Yes, so this is the integrating factor. So now remember the equation. We said y dot integrating factor will be equal to integral q dot the integrating factor. This times the integrating factor. So it means here, this will be y times 1 all over cos x. Yes, is equal to integral. Now the value of q. Now remember we said q is equal to sine x. Yes, q is equal to sine x. So here we have sine x, then the integrating factor, which is 1 all over cos x. Then here we have dx. So this is the same as saying y all over cos x. Y all over cos x is equal to integral. We have sine x all over cos x. Then here we have dx. Yes, all over cos x dx. Now, in this case, this will be equal to, we have y all over cos x will be equal to, now remember, we already have the integral of sine x all over cos x to be minus ln cos x. So here we have minus ln, here we have cos x plus the value of c. Yes, plus the value of c. So now in this case, let's multiply through by cos x. Let's multiply through by cos x. Yes. So multiplying through by cos x, multiply through by cos x. So it means for the left hand side, we have cos x times y all over cos x is equal to, we have minus ln cos x plus, sorry, we times this by cos x as well. That is cos x times minus, yes, minus ln cos x. Then here we have plus c cos x. Yes, plus c cos x. So this will go with this. So this will go with this. I'll be left with y. So y will be equal to, we have minus cos x ln cos x. Then here we have plus c cos x. Or let's call it, yes, plus c cos x. So that is the value. Yes, that's the value of y. So we can also express this as y is equal to c cos x minus cos x ln in bracket cos x. Yes. Now let's move straight to question number 3. Yes, question number 3. We have seen question number 1, question number 2, question number 3. Now question number 3, we have x, the y all over the x, the y all over the x minus y is equal to x raised to the power of 3 cos x. Yes, x raised to the power of 3 cos x. Now this is another question. Yes, another linear equation. So now the first step here is to divide through. By the coefficient of the y all over the x. That is by x. Yes, to divide through by x. So dividing through by x. Yes, dividing through by x. Here we have x the y all over the x. X the y all over the x. All over x. Minus y all over x is equal to x raised to the power of 3 cos x all over x. Yes, all over x. So now this x will go with this x. This will go with this. So we'll be left with the y all over the x minus 1 all over x y is equal to this x will go with one of this x power 3, and here we'll be left with x power 2. Yes, x power 3 divided by x is x power 2. So it means here we have x power 2 cos x. Yes, x power 2 cos x. So at this point, comparing the above equation with, we have the y all over the x plus py is equal to q. So it means in this case, when you compare these two equations, our p here, the value of p will be equal to minus 1 all over x, and q will be equal to x raised to the power of 2. Here we have cos x. Yes, x raised to the power of 2 cos x. Now let's look at the integrating factor. Now the integrating factor is equal to e raised to the power of integral p dx. Yes, so that will give us e raised to the power of integral minus 1 all over x dx. Yes, so it means the whole of this now will be equal to, we have e raised to the power of minus ln x. Yes, minus ln x. Now it means here we have e raised to the power of the integrating factor if will be equal to, we have e raised to the power of, this is ln x raised to the power of minus 1. Yes, and this is the same as saying e raised to the power of ln 1 all over x. Yes, so the integrating factor will be equal to e raised to the power of log to base e. Here we have 1 all over x. Yes, so it means this will give us 1 all over x. So the integrating factor is 1 all over x. Yes, that's the integrating factor. So the next step is to multiply through. Yes, or we just bring out the equation that y dot if is equal to integral q dot if. Yes, y times the integrating factor is equal to integral q times the integrating factor. So here we have y times, we have 1 all over x, that's the integrating factor, will be equal to integral, now the value of q. Now here we said the value of our q is x squared cos x. So here we have x squared cos x times the integrating factor, which is 1 all over x. Then here we have the x. Place the x here, please. Yes. So it means here we have y all over x will be equal to, now this x will go with one of this x here. So it means we'll be left with integral x cos x dx. Yes, x cos x dx. Now let's look at the integral of this now. Yes, let's look at the right hand side. Now for the right hand side, integral x cos x dx. Now remember integration by parts. That's integration of product functions. Here we said integral u to v is equal to uv minus integral v du. Yes, uv minus integral v du. So in this case, let u be equal to x. Yes, let u be equal to x. Now let u be equal to x and the v be equal to cos x. Yes, let u be equal to x and the v be equal to cos x. If u is equal to x, it means the u all over the x will be equal to 1. Yes, it will be equal to 1. And the u will be equal to, we have 1 dx. Yes, the u will be equal to 1 dx. Now, if the v is equal to cos x, if the v is equal to cos x dx. Yes, here we have cos x dx. If the v is equal to cos x dx, it means that v will be equal to integral dv, which is integral cos x dx. And when you integrate cos x, it gives sine x. Yes, it gives sine x. So it therefore means that here, what we have here now will be integral x cos x integral cos x cos x dx will be equal to, we have our u. And remember we said let u be equal to x. So we have x as the value of u. Then our v is sine x. Yes, v is sine x. So minus integral, we have v the u. Now v is sine x. So here we have sine x. Then the u. Now remember our du is 1 dx. So we can just call it dx. Then here we have plus c1. Yes, that's partial constant. So it means the whole of this now will be equal to x sine x minus, now when you integrate sine x, it gives minus cos x. Then here we have plus c. So it means the whole of this now will be x sine x minus minus is plus. So we have plus cos x plus c. So remember, here we have y all over x to be equal to integral x cos x dx. So it therefore means that y all over x will be equal to, we have x sine x plus cos x, then here we have plus c. So now let's multiply through by x. Multiply through by x. Yes, let's multiply through by x. It means here we have x in brackets y all over x is equal to x in bracket x sine x plus cos x plus c. Yes, plus c. It means the whole of this now will be equal to, yes, the whole of that function now will be equal to, x will go with x. Yes, the value of x will cancel x there. So it means here we have this x will go with this x. And we'll be left with y. So it means y will be equal to, we have x times x sine x. That will give us x squared sine x. Yes, x squared sine x plus, we have x cos x. Yes, x cos x. Then here we have plus c. So this is the solution. This is the value of y. So that is question 3. Yes. Now let's go straight to question 4. Yeah, that will be the question number 4. So question number 4, we have the y all over the x plus the y all over the x plus y cot x is equal to, we have 5 e raised to the power of cos x. Yeah, this is 5 e raised to the power of cos x. Now let's look at this solution. Now comparing this with the y all over the x plus py is equal to q. It means here our p, yes, our p here will be cot x. Yes, our p will be equal to cot x, and q will be equal to 5 e raised to the power of cos x. Yes, 5 e raised to the power of cos x. Now let's look at the integrating factor. Now the integrating factor will be equal to e raised to the power of integral p dx. So that will give us e raised to the power of, the value of our p here is cot x. So we have cot x dx. Yes, that's integral e raised to the power of integral cot x dx. Yes. Now let's see the value of integral cot x dx. Yes, let's see what the integral of cot x dx will give us there. So it means that here we have integral cot x dx. Now let's look at integral cot x dx. Now as we all know, cot x is the same as cos x all over sine x. Here we have dx. Yes, cot x is 1 all over tan x, which is the same as saying 1 all over sine x divided by cos x. And that will give us cos x all over sine x. So it means in this case, let u be equal to sine x. Yes, let u be equal to sine x. It means the u all over the x, you differentiate sine x, it gives cos x. So the value of our du will be equal to cos x. Then we have the x. So the x will be equal to the u all over cos x. Yes, the u all over cos x. It means integral cos x dx will be equal to integral. Now, we have cos x all over. Remember we said let u be equal to sine x. So here we have all over u. Then that's the x now is the u all over cos x. So here we have the u all over cos x. So it means this cos x will go with this cos x. So it means here we'll be left with integral 1 all over u du. Now when you integrate 1 over u, it gives ln u. Yes, it gives ln u. So it therefore means that the integrating factor if will be e raised to the power of ln u. Yes, e raised to the power of ln u. I remember we said let u be equal to sine x. Yes, let u be equal to sine x. So now, putting the value of u to be equal to sine x, it means the integrating factor, yes, if, the integrating factor will be equal to e raised to the power of log. Now we have the value of our u is sine x. So here we have sine x all to base e. So it means that will give us sine x. Yes, the integrating factor is equal to sine x. Now let's look at this now. Now we said the equation is y times integrating factor is equal to integral q times the integrating factor. Then here we have the x. Yes, so it means here we have y. Now the integrating factor is sine x. So let's put it there. Sine x is equal to integral. Now the value of q. Remember here we said q is 5 e raised to the power of cos x. So here we have 5 e raised to the power of cos x. Then the integrating factor now, which is sine x. Then here we have dx. Yes, we have dx. Now, looking at the right hand side. Yes, picking the right hand side. Integral 5 e raised to the power of cos x in bracket sine x dx. Now we have to integrate this. Yes, now if you look at this, the derivative of this will give us this. Yes, the derivative of cos x is minus sine x. So here we'll be going by integration by substitution. So here, let u be equal to cos x. Yes, that is this power here. Let u be equal to cos x. So if u is equal to cos x, it means the u all over the x will be equal to minus sine x. Yes, so the u will be equal to minus sine x. Then here we have the x. So thus the x will be equal to the u all over minus sine x. Yes, it will be the u all over minus sine x. So it therefore means that here, we are going to have integral 5 e raised to the power of cos x. Now remember we said let u be equal to cos x. So it therefore means that in place of this cos x, we're going to put u there. Yes. Then we have in bracket sine x. Yes, we have sine x. Look at it there. Sine x. Yes. Now let's see the value of the x. The x is the u all over minus sine x. Yes, the u all over minus sine x. Now, this sine x will go with this sine x. It means here we'll be left with minus because of this negative sign. Minus 5 integral e raised to the power of u. Then here we have the u. Yes. So when you integrate e power u, it gives e power u. So this will be minus 5 e raised to the power of u. Then here we have plus constant. So that will give us minus 5 e raised to the power of the value of u. I remember we said let u be equal to cos x. So it means it will be minus 5 e raised to the power of cos x. Then here we have plus constant. Yes. Now remember the right hand side. Remember this equation. Yes. Look at this equation. So here we have y sine x. Y sine x, therefore, y sine x will be equal to, now the right hand side, which is this now. We have minus 5 e raised to the power of cos x. Then here we have plus c. So at this point, let's divide through. Let's divide through by sine x. That is the coefficient of y. So it means at the left hand side, we have y sine x all over sine x is equal to, here we have minus 5 all over sine x. Then we have e raised to the power of cos x plus c all over sine x. Now recall from trigonometry. Yes, recall that 1 over sine x is equal to cosec x. Yes, recall that 1 over sine x is equal to cosec x. Now let me drop it here. Recall that 1 all over sine x is equal to cosec, yes, cosec x. That's the cosecant of x. It therefore means that here, this will go with this. And on the left hand side, we left with y. Y will be equal to, now, 1 all over sine x is cosec x. So this will be minus 5 cosec x. Then here we have e raised to the power of cos x. Then here we have plus, here we have c cosec x. So it means here the value of y can also be expressed as c cosec x. Yes, c cosec x minus 5 cosec x, then e raised to the power of cos x. So this is the value of y. Yes, that's our y. So that's the solution to question number 4. So now we are going to look at the last question there. That is question number 5. Now let's pick it up. Question number 5. We have 1 plus x squared. 1 plus x squared. The y all over the x. The y all over the x will be equal to, plus. We have plus 3xy. 3xy is equal to, we have 5x. Here we have 5x. Now, solving this solution. Now, the first step is to make the coefficient of the y all over the x to be equal to 1. Yes, the coefficient to be equal to 1. So, in that case, it means we are dividing through by the coefficient of the y dx. So, divide through by 1 plus x squared. Yes, divide through by 1 plus x squared. So it means here we have 1 plus x squared. The y all over the x, divide by 1 plus x squared. Yes, this is 1 plus x squared, please. Plus, we have 3xy all over 1 plus x squared is equal to 5x all over 1 plus x squared. Now we have divided all through by the coefficient of the y all over the x. Yes, we have divided all through by the coefficient of the y all over the x. So it therefore means that here, this will go with this. Yes, this will go with this. So you'll be left with the y dx. The y all over the x. Now plus 3xy all over, here we have 1 plus x squared is equal to 5x all over 1 plus x squared. Yes. Yes. The y all over the x plus 3xy all over 1 plus x squared is equal to 5x all over 1 plus x squared. Now, in this case, now let's compare. Let's compare with the y all over the x plus py is equal to q. Yes, it's equal to q. Now, the position of p, our p there will be equal to, we have 3x all over 1 plus x squared. Yes, 3x all over 1 plus x squared. And our q, the value of q, is 5x all over 1 plus x squared. Yes, we have seen p and q. Now the next step is to look for the integrating factor. So here, IF. Remember, we're using IF to designate or represent the integrating factor. So IF, we said, is e raised to the power of integral p dx. Yes, and this will be equal to e raised to the power of integral the value of p. Now remember, p is 3x all over 1 plus x squared. Then here we have dx. Yes, we have dx. This is 1 plus x squared dx. So in this case now, please, I want us to look at this now. Let's look at integral 3x all over 1 plus x squared dx. Yes, let's look at this. Now, in this case, if you look at the denominator, yes, when you differentiate the denominator, it gives 2x. Yes, it gives 2x. So this is a case of integrating functions where the derivative of the denominator is equal to the numerator. So at this point, let u be equal to 1 plus x squared. Yes, let u be equal to 1 plus x squared. Now, if u is equal to 1 plus x squared, the next step is to find the u all over the x. Yes, is to find the u all over the x. So now the u all over the x, will be equal to, we have 2x. It will be equal to 2x. So it means the u will be equal to 2x dx. The x will be equal to the u all over 2x. Yes, the x, to get the value of the x, you divide both sides by the coefficient of the x. And the coefficient of the x there is 2x. So it means the integrating factor here. Now, let's look at this now. The x is the u all over 2x. So it means integral 3x all over u. Or let me call it 1 plus x squared first. Yes, the x will be equal to integral, we have 3x all over u. Because we said let u, yes, look at it here. Let u be equal to 1 plus x squared. So here, dots times the value of the x. The x is the u all over 2x. Yes, the u all over 2x. So this x will go with this x. We will left it 3 all over 2 integral 1 all over u du. Now when you integrate 1 over u, it gives ln u. So this will be 3 all over 2 ln u. Which is the same thing as saying 3 all over 2 ln. Now the value of u, we said let u be equal to 1 plus x squared. It means here we have 1 plus x squared. Yes, 1 plus x squared. So now the integrating factor, IF, the integrating factor will be equal to e raised to the power of, we have 3 all over 2 ln 1 plus x squared. Yes, and this is the same as saying e raised to the power of ln 1 plus x squared all raised to the power of 3 all over 2. All raised to the power of 3 all over 2. So the whole of this now will be equal to, yes, the whole of this now will be equal to, we have IF, the integrating factor, will be equal to e raised to the power of log to base e. We have 1 plus x squared all raised to the power of 3 all over 2. Yes, so this will be equal to 1 plus x squared raised to the power of 3 all over 2. So that's the integrating factor. Now the equation will be y times integrating factor will be equal to integral. We have q times integrating factor. So here we have y times this value. That is 1 plus x squared all raised to the power of 3 all over 2 will be equal to integral. Now the value of q. The value of q, remember we said let q be equal to, we said let q be equal to 5x all over 1 plus x squared. So we have 5x all over 1 plus x squared. That's the value of q. Yes, that's the value of q. Then times the integrating factor. The integrating factor is 1 plus x squared all raised to the power of 3 all over 2. Then here we have the x. So please, there's the x there. So here we have the x. So it means the whole of this, y in bracket 1 plus x squared all raised to the power of 3 all over 2 will be equal to. Now let's look at this. Let's look at this. We all know from indices, yes, from indices, that a raised to the power of x divided by a raised to the power of y is equal to a raised to the power of x minus y. Yes, it's equal to a raised to the power of x minus y. So it therefore means that the whole of this function will be integral. We have 5x in bracket 1 plus x squared all raised to the power of 3 all over 2 minus 1 dx. Because this is the same as saying power 1. 1 plus x squared raised to the power of 1. So this all over this. So we are applying the law of indices. We are subtracting the powers. So it therefore means that y in bracket 1 plus x squared all raised to the power of 3 over 2 will be equal to, now this will be integral. We have 5x, then this will be 1 plus x squared. Now 3 all over 2 minus 1. 3 over 2 minus 1 over 1. The LCM is 2. 2 into 2 is 1. 1 times 3 is 3. Minus 1 into 2 is 2. 2 times 1 is 2. So 3 minus 2 is 1. So here we have 1 all over 2. Then here we have dx. 1 all over 2 dx. So now let's look at the right hand side. Yes, looking at the right hand side. Yes, looking at the right hand side. Now we are integrating. Integral. We have 5x. Then here we have 1 plus x squared all raised to the power of half. Then here we have dx. Now, this is the case whereby when you integrate, when you differentiate the coefficient, it gives the other function. Yes, it gives the other function. So in this case, let u be equal to 1 plus x raised to the power of 2. Yes. Here now, the u all over the x will be equal to 2x. The u will be equal to 2x dx. So the x here will be equal to the u all over 2x. Yes, that's the x. The x is the u all over 2x. So it means the whole of this function will be integral. We have 5x. Then here we have u. Because here we said let u be equal to 1 plus x squared. So here we have raised to the power of half. Dot. Thus the x now is the u all over 2x. So this x will go with this x. So the whole of this now will be 5 all over 2 integral u raised to the power of half. Then here we have the u. Yes, u raised to the power of half the u. So it means the whole of that now will be equal to, yes, it will be equal to, yes, it will be equal to, we have 5 all over 2. Now let's integrate u power half. U power half now will be u raised to the power of half plus 1 all over half plus 1. Then here we have plus constant plus c. It means the whole of this now will be equal to, we have 5 all over 2 in brackets u raised to the power of 3 all over 2 divided by 3 all over 2. Then here we have plus c. Yes, so this 2 will cancel this 2. Yes, so it means we have 5 all over 3 u raised to the power of 3 all over 2 plus c. Yes, so this will be equal to, we have 5 all over 3. Now recall, we said let u be equal to 1 plus x squared. Yes, let u be equal to 1 plus x squared. So here we have 1 plus x squared. Then here we have raised to the power of 3 all over 2 plus c. Yes, plus c. So remember, the right hand side, or let me call it left hand side is equal to right hand side. Yes. Now for the left hand side, we have this. Yes. We have y in brackets 1 plus x squared raised to the power of 3 all over 2 is equal to, that's for the left hand side. Now the right hand side, we have 5 all over 3. Yes. We have 5 all over 3 in brackets 1 plus x squared all raised to the power of 3 over 2 plus c. Yes, plus c. Yes. So now at this point, let's divide through by the coefficient. Let's divide through by the coefficient of y. And the coefficient of y is 1 plus x squared all raised to the power of 3 all over 2. Yes, 1 plus x squared all raised to the power of 3 all over 2. Yes. So it therefore means that here we have y in brackets 1 plus x squared raised to the power of 3 all over 2 divided by 1 plus x squared raised to the power of 3 over 2 is equal to, we have 5 all over 3 in brackets 1 plus x squared raised to the power of 3 over 2 divided by 1 plus x squared raised to the power of 3 over 2. Then we have plus c all over. Yes, because we are dividing through the whole of this, both the left hand side and of course the right hand side, by 1 plus x squared raised to the power of 3 over 2. So here we have 1 plus x squared raised to the power of 3 over 2. So this will cancel this. Yes. And here we'll be left with y. Now this will cancel this. We'll be left with 5 all over 3. And here we have plus c all over 1 plus x squared all raised to the power of 3 over 2. Yes. So this can also be expressed in this form. Y will be equal to 5 all over 3 plus c. And here we have 1 plus x squared all raised to the power of minus 3 all over 2. So this is the equation. Yeah, this is the equation. So now we have actually come to the end of this class. Now we have seen how to use the integration by integrating factor to analyze linear differential equation. So if you enjoyed this video, remember to subscribe, like, and share. Thank you so much, and God bless you.